Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, I have designed edge coupled or parallel coupled microstrip bandpass filter. So now here in this video, I am going to design Hairpin-Line microstrip bandpass filter using HFSS software. So before going to the design, what is Hairpin-Line microstrip bandpass filter? Hairpin-Line bandpass filters are compact structures. They may conceptually be obtained by folding the resonators of parallel coupled half-wavelength resonator filters into U-shape. In my previous video, parallel coupled half-wavelength resonant filters are designed. So now here, the parallel coupled half-wavelength resonant filters into U-shape. This type of U-shape resonators is called as a hairpin line resonator. In this design, a microstrip hairpin bandpass filter is designed to have a fractional bandwidth of 20% or 0.2 at a midband frequency of 2 GHz. So now here I am selecting the operating frequency is 2 GHz. A 5-pole Chebyshev low-pass prototype filter a 5-pole Chebyshev low-pass prototype filter with a passband ripple of 0.1 decibel is considered. The low-pass filter prototype parameter. So that low-pass filter prototype parameters of the normalized low-pass cutoff frequency is 1 radians per second, and G naught the general values of the low-pass prototype filters are G0, G6 are 1, G1 and G5 are 1.14, G2 and G4 are 1.37, and G3 is 1.97. So now here I am selecting the type of the material is Rogers RT or Durite 6006 with its dielectric permittivity constant is 6.15, and I am considering the thickness of the substrate is 1.27 mm. So now here in this design, it should be noted that the hairpin resonators used to have a line width of 1 mm. So this is the hairpin lines. So this line width of the hairpin line resonator is 1 mm, and the spacing and the separation between two pins is 2 mm. And another important dimension of the resonator as indicated by the length of the hairpin. So this length of the hairpin is half of quarter wave of the guided wavelength. So the quarter wave of the guided wavelength can be determined using this expression. So now where the uh, uh, epsilon r is 6.15 and operating frequency is 2 GHz, and substitute that values into this equation, we get guided wavelength, and the length of the hairpin is half of the guided wavelength. And I am considering, and this is the 50 ohm transmission line, this end and this end is the 50 ohm transmission line. The width of the 50 ohm transmission line I am considering 1.85, and length of the 50 ohm transmission line is 4.6. And adding all these values, so this length is 4.6, this length is 4.6, this hairpin line width is 1, and this separation is 2 mm. Now where the spacing is 0.4, this spacing is 0.6. This is 5-pole hairpin line microstrip bandpass filter. Adding all these values, the length is 31.2 mm. So I am considering the length and width of the substrate is 31.2 mm and 30 mm. Now open HFSS software. So first draw the substrate, select the box, draw the box anywhere in the plane. So give the rename of this box 1, this is substrate, and change the type of the material. The type of the material is Rogers So Roger's RT are derived 6006 and its dielectric constant is 6.15. So now change the dimensions of the substrate. So the length of the substrate is, that is X size is 31.2 mm and width of the substrate is 30 mm and height of the substrate, the thickness of the substrate I am considering 1.27 minus 1.27 mm and position, X position value is half of the X size value before representing negative sign minus 31.2 by 2 and Y position is half of the Y size value before representing negative sign and Z position is 0. Press OK button, select fit all. So this is the substrate. So below the substrate we can design ground plane. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet. This is the ground plane. So the dimensions of the ground plane is same as that of the dimensions of the substrate and the length of the ground plane is 31.2 mm and width of the ground plane is 30 mm and X position is minus 15.6 mm minus 15 mm and Z position and height of the substrate is 1.27 mm. So that ground plane is below the substrate, so the Z position is minus 1.27 mm. So rotate this structure and this is the ground plane. So on the top of the ground plane is substrate. So on the top of the substrate we can design 50 ohm transmission line, 5 port hairpin line microstrip band pass filter. So first design 50 ohm transmission line. Select the rectangular sheet. Draw the rectangular sheet anywhere in the plane. Give the rename of this one. This is 50 ohm transmission line. So now change the dimensions of the 50 ohm transmission line. Axis is the Z axis. So now here I am considering the length of the 50 ohm transmission line is 4.6 minus 4.6 and width of the 50 ohm transmission line is 1.85 mm and position and X position is the length of the substrate is 31.2 and half of its value, that is 15.6 mm, that is X position value 15.6 mm and Y position. So this is placed in and Y position is 4. So using this expression, a proposed estimating tapping point T is equal to 2L by pi sine inverse of square root of pi by 2 Z0 by ZR by Q suffix E. Using this expression, calculating the tapping point. So now here the tapping point is 4 mm, that is the Y position 4 mm and Z position is 0. So press OK button. And draw another 50 ohm transmission line. Select this 50 ohm transmission line, press Ctrl C, Ctrl V. So change the dimensions of this pasted element of the 50 ohm transmission line. This is minus 15.6 mm and X size is plus 4.6. Press OK button. So this is another end of the 50 ohm transmission line. And after that draw the hairline pins. Select the rectangular sheet. Draw the rectangular sheet anywhere in the plane. So now here this hairpin line. So this length is 18.5 and the total 20.4 mm. So using this expression, calculate the using half wave guided wavelength, calculate the length of the hairpin, that is 20.4 mm, and this length is 19.4 mm. Change the dimensions of this line, and length y size, that is 19.4, and x size is, that line width is 1 mm. This is 19.4 mm, and that line width is 1 mm, and position and x position is, and the x position value of the 50 ohm transmission line is 15.6 mm, and now here the length of the 50 ohm transmission line is 4.6 mm, and subtracting that value from x position value of the 50 ohm transmission line 15.6, the 50 ohm transmission line x position is 15.6 minus, and the length of the 50 ohm transmission line is 4.6 minus, so this width is 1 mm minus 1, so the x position value of the this line is 10 mm, 10 mm, and y position is, and half of the y size value before representing negative sign. So now here the y size is 19.4 by 2 before indicating negative sign. Now press OK button. So this is, so now select this rectangular sheet, press Ctrl C, Ctrl V. So change the dimensions of the tested element, and x position is -10, and this x size is -1. Press OK button. This is another end of the line. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane. So now change the dimensions of this rectangular sheet. So now here the line width is 1 mm, that is x size. X size is 1 mm, and the spacing is 2 mm. And this is x-axis, that spacing is along the x-axis. This is 2 mm, and y size width is 1 mm. So now select this rectangular sheet, rectangle, press Ctrl C, Ctrl V. So change the dimensions of the pasted element of the rectangle, and this is -10, and this is +2. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. So now change the dimensions of this rectangular sheet. This rectangular sheet length is 19.4 minus 19.4 mm and width is 1 mm and position and exposition is and previous this rectangular sheet exposition is 10 mm and the spacing is 2 mm. 8 minus this rectangular sheet exposition is 10 mm and the spacing is 2 mm. So 10 minus 2, 8 mm. So now the exposition is 8 mm and y position is 9.7 mm. Z position is 0. Now press the OK button. Select this rectangular sheet. Press Ctrl C, Ctrl V. Change the dimensions of the pasted element of the rectangular sheet. And this is minus 8 and X size is plus 1 mm. Now here the spacing is 0.6, 0.4 mm. And this is a 5 pin, 5 pole hairpin line. First pin, second pin, third pin, fourth pin, fifth pin. And this pin both are same and this pin and this pin both are same. Next draw the this pin. And the spacing between these two pins is 0.4. Select the rectangular sheet. Draw the rectangular sheet anywhere in the plane. So change the dimensions of this rectangular sheet. So now here this rectangular sheet length is 20.4 mm. This length is 20.4 mm. And width is 1 mm and exposition. So this rectangular sheet exposition is 8 mm and this gap is 0.4 mm. 8 minus 0.4, 8 minus 0.4, 7.6 mm and 7.6 mm and this rectangular width is 1 mm minus 1, so the exposition is 6.6 mm. And Y position is 9.7 mm. Z position is 0. And select this rectangular sheet. Press Ctrl C, Ctrl V. Change the dimensions of the pasted element of the rectangular sheet. And this is exposition is minus 6.6. X size is plus 1 mm. This is select the rectangular sheet. Draw the rectangular sheet anywhere in the plane and change the dimensions of this rectangular sheet. and the spacing is 2 mm, and Y size is select this rectangular sheet, Control C, Control V. So change the dimensions of this one. This is minus 5.6 and this is plus 2. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. So change the dimensions of this rectangular sheet. And now here this rectangular sheet exposition is 5.6 and the spacing is 2 mm. 5.6 minus 2, 3.6 mm. So this exposition is 3.6 and this is minus 10.7 mm. That portion is 0 and x size that width is 1 mm minus 1 and length is 20.4. Select this rectangular sheet, press Ctrl C, Ctrl V, change the dimensions of the pasted element and exposition is minus 3.6, x size is plus 1. So next draw this pin. So the spacing between these two pins is 0.6 and this line exposition is 3.6. So 3.6 minus 0.6, 3 and this line width is 1 mm. So this line exposition is 2 mm. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. So change the dimensions of this rectangular sheet and width is 1 mm minus 1. This is minus 20.4 mm and exposition is 2 mm and Y portion is 9.7. Z portion is 0 mm. Next select the rectangular sheet, draw the rectangular sheet anywhere in the plane. Okay. Select this rectangular sheet. Select this rectangular sheet. Press Ctrl C, Ctrl V. Change the dimensions of this rectangular sheet. This is exposition. This exposition is minus 2 and x size is plus 1. So now select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. So change the dimensions of this rectangular sheet. X size is 2 mm and Y size is minus 1. So this is 5-pole hairpin microstrip band pass filter. So this is the first hairline pin, second hairline pin, third hairline pin, fourth hairline pin, fifth hairline pin. 5 poles. So the spacing between here and here is 0.4. The spacing between here and here is 0.6, and this line width is 1 mm and the spacing is 2 mm. So now select the suitable rectangles. Use unite button. Select 50 ohm transmission line, rectangle 1. Select 50 ohm transmission line using control button. This rectangular sheet. This rectangular sheet. And this rectangular sheet. So press unite button. So this is unit. So similarly, select this 50 ohm transmission line, this rectangular sheet, this rectangular sheet, this rectangular sheet. Click unite button. So similarly, select this rectangular sheet, this rectangular sheet, this rectangular sheet. Click unite button. Here also select this rectangular sheet, this rectangular sheet, this rectangular sheet. Press unite button. Here also select this rectangular sheet, this rectangular sheet. So all are unique. So now rotate this structure. Assign port 1 and port 2. And this is y axis and this is z axis. Change the plane, yz plane. Select the rectangular sheet. Draw the rectangular sheet anywhere in the plane. Give the rename of this rectangular sheet. This is port 1. So change the dimensions of the port 1, and y size is 1.85, that is the width of the 50 ohm transmission line, and the height of the substrate is 1.27 mm. So z size is minus 1.27 and x portion is 15.6 and y portion is 4 mm, z portion is 0. Press OK button. And similarly draw another end of the port. Select this P1, press Ctrl C, Ctrl V, change the dimensions of the pasted rectangular sheet. Not 88. And X portion is minus 15.6 mm. So this is another end of the port. Now assign lumped port excitation of port 1 and port 2. Select this rectangular sheet. Right click on the rectangular sheet. Go to assign excitation. Select lumped port. Draw the new line integration from lower port to upper port. Successfully defined. Click finish button. So this is port 1 lumped port excitation. Similarly assign lumped port excitation of another end of the port. Select this rectangular sheet, right click on this rectangular sheet, go to assign excitation, select lumped port, draw the new line integration from lower port to upper port. Successfully defined. So now coming back to the XY plane, And now assign perfect electric boundary. Select this rectangular sheet, this 50 ohm, this 50 ohm, this rectangle, and this rectangle, and ground plane. Right click on that portion, go to assign boundary, select perfect E boundary. So this is perfect E boundary. Next assign analysis setup, go to the simulation, select advanced. So now the operating frequency is 2 GHz. I am selecting maximum number of passes are 12, maximum delta S is 0.02. So press OK button, and sweep type is fast, and minimum frequency is starting frequency is 1 GHz, ending frequency is 3 GHz, and points I am selecting 101. Press OK button. Select open region radiation boundary, go to the model, right click on the model, select create open region, click OK button. So this is open region boundary. Now check the design validation, click validate. So design is successfully validated, and now start the simulation, press analyze all button. So simulation is completed. So now observe the S parameter, return loss and insertion loss curve. Go to the results, right click on the results, create model solution data report, select rectangular plot, select S parameter S11, S21 in decibel, click new report. And this red color curve is return loss curve, and green color curve is insertion loss. So that is band pass filter response curve.